Okay, yeah, let's continue with the theme of allostery. What are the biggest misconceptions scientists still have about allosteric modulation? Yeah, that's a deep question, and there's pros and cons. One of the most important ones that I encountered years ago, chemists like to think sterically. They, they have a site they like to dock into it, so forth. The idea that proteins are malleable, coiled springs moving all the time is it's a step away from that. So there is this idea that allostery is uh, magic. It's complex. It does stuff that no one understands. Well, the field has really moved beyond that. It was developed in the 70s. Monod, Wyman, Changeux, these people defined the equations and the systems. But since then, it's gone way beyond. We have models, and we can actually put numbers on to what's happening. So in the end, it becomes like an orthosteric program. You get a curve and you fit it to a model, and out comes numbers that chemists modify. The other thing that's new is structure. Now, a lot of chemists are heavily dependent on structure, and with dynamics, we're identifying cryptic binding sites. So, and what these are is you can have an X-ray structure A, and then dock in something else and an X-ray structure B, and that's all you've got. Dynamics can then do a movie between what happened between A and B, and what they're seeing are sites open and shut in that process that an allosteric says, there it is, and jumps in. In other words, developing allosteric binding, which was always an issue, is now greatly enhanced with dynamics and structure. So there's a lot more that chemists can use for that process. So I'll just end this with saying allostery is not to be feared, it's to be embraced. There's a lot of opportunity there. The caveat being that you're going to get a complex molecule that may be a little more difficult to assess in animals and people and so forth. But and so that was the question. I'll just make sure I got biggest misconceptions. Yeah. The other thing is, okay, let's say this, that some people might think, well, who cares? Why do I want an allosteric? I'll get an orthosteric, because allosterics can do so many things that an orthosteric molecule cannot do. So you greatly expand your spectrum of responses. An orthosteric molecule binds to the target and hijacks it. It turns natural signaling off and imposes its own profile. And allosteric works hand in hand, partnership with natural signaling, and you can get a far greater spectrum of effects with these. So I'll stop at that point.
Yeah, I really like how you mentioned, that an orthosteric ligand would hijack. It sounds more like a dictatorship versus a leadership position, where leaders just tend the allosteric molecule works with the system, works with a natural ligand, and helps modulate it, instead of imposing their function on the receptor.
Mm-hmm. Yeah.